I'm Mr. Franklin, and this is the toothpick bridge video. So first thing we're going to do is we're going to look at how does a toothpick bridge actually work. So from a very basic standpoint, we have the base that we're going to be setting our bridge on, okay? And it's going to have to hold a weight. So that's what I've drawn here, is drawing a side view, and you've got the base here. And then very basically, you just need a roadway that goes across, okay? Now this one has extra structure, but that's extra. The very basic thing that you need is a base with a roadway. Now, let's add to our drawing. So here in the middle is where we're gonna have this block with a bolt through it that's gonna run through your bridge, and it's gonna hold a weight. Okay, so we're going to have a weight, which is the force due to gravity. Okay, and from a very basic standpoint, if we have a weight pulling down, guess what's going to happen? So that weight is pulling down, so it's actually, where are we feeling that weight? We're going to feel it on the ends. And then there's going to be a reaction force, okay? So we're going to have a force here and a force here. So what physics concept are we probably going to be concerned with here? Okay? Hopefully you were right in your thinking, but we're going to be looking for net force. We're going to be looking to add up all of the forces. Force of gravity plus force 1 plus force 2. And as long as the bridge doesn't go anywhere, what's that going to equal? It is going to equal 0. Okay? So, if we add structure, we add other things to it, we greatly increase the forces and it gets a lot more complicated, but from a very basic standpoint, that's what we're doing with our bridge. Well, let's look at it from a top view. What does our bridge have to have from a top view? Now, I'm going to point out, I may miss a detail, so make sure that you're looking at your POP requirement sheet that's posted in Canvas. But top view, I have to have a roadway, and in the middle of it needs to be a hole. And this hole has to be at least a 1/2 inch in diameter. Okay? And that is so we can put the bolt through the hole of our bridge. Okay, so we're going to have to put the block through there and fit the bolt through the hole of our bridge so that now I can hang a weight. The base, the bridge, has a minimum requirement of 12 inches. Okay, in between the base, there is a space, an empty space of 10 inches. So you got 10 inches here, and you should have 1 inch on this side of the base and 1 inch on this side of the base. What's the width of our bridge? Our width can't be more than 3 inches. Can't be less than 3 inches. It needs to be 3 inches wide. Okay. So what are some questions we should probably be asking about our projects here? Okay, or maybe what's the physics? Okay. Well, one of them might be simply, what's the strongest bridge? We might find all kinds of designs for that. Now, part of our requirements though is we are allowed to put structure on our bridge. So we're allowed to have, some people do it as X's or triangles, okay? We're allowed to have this. And the height of this has to be greater than, has to be at least 2 inches tall so that we can drive the car on the roadway, and then it can sit on the roadway and hold the weight. So the height can't be more than 2 inches, okay? Any structure below can't be more than 2 inches below. Okay, so the height from below the roadway can't be more than 2 inches below. So we can add structure. When I start adding structure, I'm adding the number of forces, which actually means I'm spreading things out, okay? Now, just as a helpful hint, because we haven't talked about this in class, this kind of design is called a truss, okay? Not trust, but truss, T-R-U-S-S, truss. So we might actually add to this, what is the strongest truss bridge? We might be looking for something like that, okay? It doesn't have to be that shape. I've actually had some bridges that do this, where there's actually a curve to it. It's just a single roadway and it's curved. It's called an arched bridge. So if you have a different design, you might put that in there as well and see what comes out, okay? So what are some physics we're looking at for our research? Net force. We might be looking at trusses. What in the world is a truss? When we do trusses, we have to think about compression and tension. Okay, how do these forces interact with each other? We might be looking at drying and curing of glue. How does gluing actually work? That's of glue. How does glue actually work? Might help us make a stronger bridge. Okay? So what are some other questions you might have about this bridge? Okay? What are some questions before we actually build the design? Because there's 1,000 ways to do this, okay? And so we need to think about, how does this actually work before we start spending hours and hours gluing little bitty tiny toothpicks together, okay? Alrighty, we'll talk soon about this some more in class. Thank you.